Okay, in this problem we're asked to use the given change of coordinates to evaluate our double integral over our region R. So our integral is of 2x minus 3y, all times the sine of x plus y, and then times our unit of area. And our region R is defined as 2x minus 3y is between 0 and 6. And then x plus y is between 0 and pi. So first, and then they also give us that uv is equal to phi inverse of xy is 2x minus 3y, comma, x plus y. Okay, so first, let's graph our region. Just to get a visual idea of what the area that we're integrating over. So our boundary for 2x minus 3y is equal to 0 and equal to 6. So first off, we have when it's equal to 0, we have the equation y is equal to 2/3 x. And then when we're at 6, we're at y equals 2/3 x minus 6 over 3 minus 2. So these are our two bounds. So if we draw the line y equals 2/3 x and the line y equals 2/3 x minus 2, we have so this is y equals -2. So when x is 0, y is -2 on the second line. And we're at the origin when x is equal to 0. And then we have the slope of both of them is 2/3. So these two lines are parallel. And then, so we're between these two lines. So that means we're looking at the area just kind of between these two parallel lines. And then for our second condition, we have x plus y is ranging between 0 and pi. So that means we're between the lines y equals -x and y equals pi minus x. So y equals -x. More or less like that. And then when y equals pi minus x, something like this. Sorry for the curvy lines. They should be straight and parallel with a slope of -1. And then this point is y equals pi. Okay, so we're looking at the region in between these two lines. So greater than that and less than that. So that means we're looking at integrating over this region. It's kind of tilted rectangle, rhombus-like shape. So that's our region R. So now we want to use our change of coordinates. So we're given that u is equal to 2x minus 3y. and v is equal to x plus y to evaluate our double integral. So first we want to just make sure that the change of coordinates that's given is a smooth change of coordinates. So we can do that just by explicitly producing phi and phi of x, or phi of uv. So that means solving in terms of x and y. So we can multiply. So if we take u minus 2v, then our x's will be 2x minus 2x. So we get our x's cancel, and then our right-hand side turns to negative 3y minus 2y, negative 5y. So we can solve for y, divide both sides by negative 5. So we get y is equal to 2v minus u over 5. And then we can solve for our x term by we can just plug in substitution for y. So we have y is equal to, we'll use this equation. So we have v. So we'll solve for x, bring this negative y to this side. So v minus y. And y is given here, so we'll do v plus u minus 2v over 5. So really this is 5v over 5. We have a common denominator. 5v minus 2v is 3v. So we have u plus 3v over 5. And we get our x and our y in terms of u and v. Okay. So now we have our phi of uv. So we have our xy is equal to phi of uv. So x is equal to u plus 3v all over 5. And y is equal to 2v minus u over 5. And these are both infinitely differentiable, so we have a smooth change of coordinates. So that makes sense since we're said that we're given change of coordinates. So now we want to evaluate our integral using our substitution that we're given. So our limits of integration. So for u, we have u is equal to 2x minus 3y. So conveniently, our u ranges from 0 to 6. And then our v is x plus y, which ranges conveniently again from 0 to pi. So our limits of integration are given as our region R is bounded. And then similarly, we have u is this first term, 2x minus 3y, and then v is going to be the interior of our sine. So our function also simplifies quite nicely. Now our element of area, dA, we know that our element of area is the absolute value of the determinant of our Jacobian matrix of phi. So that means that we're taking our partial derivatives of our first component of phi as our first row, and the partial derivatives of the second component of phi as our second row. And so we'll take our partial derivative with respect to u first. So partial derivative of u in our first component is u over 5, which is 1/5. Partial derivative with respect to v is 3/5 v, which is just 3/5. So our first row is 1/5, 3/5. And then our second component, we want to again take the partial derivative with respect to u first, since that's what we did with our first component. So we have negative u over 5, which is negative 1/5. And then our partial derivative of our second component with respect to v is 2/5 v, which turns to 2/5. And then du dv. Okay, so the determinant, sorry, this should say the determinant of this matrix. So the determinant of this matrix is 1/5 times 2/5 minus a negative 1/5 times 3/5. So one-fifth times 2/5 is 2 over 25 minus a negative 1/5 times 3/5 is a negative 3 over 25. So we can add 3 out of 25, which simplifies to 5 out of 25, or 1/5. And this should be du dv. So we have 1/5 du dv. Okay, so we have all of our information in order to change our double integral into in terms of u and v. So we can go ahead and do that. So again, this first term is just u. Second term is sine of v. So we have u sine v. dA, remember, we just computed as 1/5 du dv. So we'll bring 1/5 on the outside. Okay, and we wrote it in terms of du dv, so that means our interior integral needs to range from our u limits of integration, which are from 0 to 6. And then our outside integral is going to be our limits of integration for v, which is from 0 to pi. And at this point, it makes sense that our limits of integration would have pi in it, since our function for v is a trig function. So it would make sense that v would be in terms of pi instead of u. Okay, so now we want to integrate with respect to u first. So the integral of u is u squared over 2. So we have So 1/2 times 1/5 is 1/10 times the integral from 0 to pi of u squared sine v, where u is evaluated from 0 to 6 dv. Okay, so when u is equal to 6, we have 36 sine v. And then when u is equal to 0, we have our function is equal to 0. So our integral is 1/10 10th, or so our integral is 36 over 10, evaluated from 0 to pi. The integral from 0 to pi of sine v dv. The integral of sine of v is negative cosine. So 36 over 10 is 18 over 5. Cosine v evaluated from 0 to pi. Okay? Cosine of pi is negative 1, so negative 18 over 5 times negative 1 is 18 over 5. Minus cosine of 0, which is 1, so minus a negative 18 over 5 plus 18 over 5. So we get our integral evaluates to 36 over 5. So we were given u and v to substitute and use as a change of coordinates to evaluate our integral. We did so. We made sure that first that u and v was a smooth change of coordinates, and then we determined that our integral evaluates to 36 over 5.